Okay, here I'm going to show you an example of how to use the squeeze theorem to evaluate a limit. So if I have this limit to do, the first thing I'm going to try is to use substitution and evaluate it by substituting 0 in for x. But that leaves the input of sine as 3 pi divided by 0, which is undefined. Okay, so we can't evaluate this limit using direct substitution. The way I'm going to use the squeeze theorem to do it is I'm going to use the fact that the absolute value of the sine of any angle is less than or equal to 1. Okay, so sine of theta always goes back and forth between -1 and 1, so the absolute value of sine of theta is less than or equal to 1. Okay, so in particular, if theta is equal to 3 pi over x, we have sine of 3 pi over x. So as long as 3 pi over x is a real number, which it's going to be for all x other than 0, the sine of that in absolute value is going to be less than or equal to 1. Using that fact, that for x not equal to 0, this is true, we're going to establish an inequality involving this. So the way we can start by doing that is take the absolute value of the inside. Well, not the inside, but the whole function. Okay, using properties of absolute values, we can write this as the absolute value of x cubed times the absolute value of sine of 3 pi divided by x. Okay, now since the sine of 3 pi over x in absolute value is less than or equal to 1, as long as x is not equal to 0, the absolute value of x cubed times this is going to be less than or equal to the absolute value of x cubed times 1, which is just the absolute value of x cubed. So what we've just established is that the absolute value of x cubed times the sine of 3 pi over x is less than or equal to the absolute value of x cubed as long as x is not 0. Okay, so we have one more thing to do before we can apply the squeeze theorem. You see that what I've established is an inequality for the absolute value of this. I need to establish an inequality for this. So I'm going to use the following property. Okay, suppose the absolute value of x is less than or equal to a for some number a that's not negative. Then we know that x has to be less than or equal to that number and greater than or equal to the negative of that number. So we can apply that property to rewrite this inequality here. In this case, x cubed sine of 3 pi over x played the role that x did here, and the absolute value of x cubed played the role that a did here. So you'll see that what we did was we took x and we scrunched it between the positive of that number and the negative of that number. So the analog here is we'll take the inside of the absolute value and we'll scrunch it between the positive of this and the negative of this. Okay, so this inequality here is true as long as x is not 0. But we don't care about x equal to 0 because we're only concerned for what's happening to this function for values of x near 0. Okay, so now to evaluate the limit of this, we're going to use the inequality that we just established. So we take a look at what happens as x goes to 0 of this, negative absolute value of x cubed as x goes to 0 goes to negative absolute value of 0 cubed, which is just 0. Likewise, as x goes to 0, the absolute value of x cubed goes to the absolute value of 0 cubed, which is also 0. Therefore, by the squeeze theorem, since this side goes to 0 as x goes to 0, and this side goes to 0 as x goes to 0, the inside must also go to 0 as x goes to 0. Hence, this limit is equal to 0 by the squeeze theorem. Okay, so that's how the squeeze theorem works.